425 people were randomly selected and asked which color they prefer. The data is given in the table. We're going to use this table to answer questions A through D. Part A. What is the probability a person selected is a child? So now we're just talking about a child over the total, right? You're picking from everybody. Well, there are 278 total children out of 425 total people. So there's your probability as a fraction. We're going to go ahead and change that to a decimal to the nearest thousandths, and we end up with 0.654 for our probability. Letter B. What is the probability a person is an adult who also likes red? So now we're talking about adult and, let me go ahead and just write that out, and red. Well, adult and red, that's right here. So you're looking for the overlap. Adult and red out of everybody. Because it doesn't say given anything or if. No, what's probably just picking a person who happens to be adult and they like red. So adult and red is 64 out of the total 425. Now, to change that to a decimal, we divide and we end up with 0.151 to the nearest thousandths. Part C, what is the probability a person likes the color green given the person is an adult? So now you are only looking at the adults because it says given the person is an adult. So you have all the adults in the room. What's probably the person likes green? So now we're talking about green over the total adults. All right, well, let's look at that. In this circled adult orange piece here, 83 of them like green. So we're going to have 83 over the total of adults, which is 147. So 83 over 147 gives us a decimal of 0.565 to the nearest thousandths. And part D, what is the probability a person is a child or likes red? Key word here is or. Or implies addition. So we've got the probability of a child plus the probability of red. But remember, if we think about child and we think about red, notice how we are counting this piece twice. So we're going to subtract the probability of a child and somebody who likes red because we counted that twice. So the probability of picking a child is 278 out of 425, right? Total children out of the total. Plus, how many people like red? Well, there's 190 red out of the total 425. And we're going to subtract the overlap. And the overlap is the 126 children who like red because we counted them twice. We counted them as children and we counted them as people who like red. So when I do this, notice my denominators are the same. So that stays 425. When I add 278 plus 190 and then I subtract 126, I end up with 342. And that gives me a decimal of 0.805. So there's my probability. Remember, probability goes from 0 to 1. So the closer you are to 1, the higher the probability. So this being a 0.805, we have a pretty decent chance of this happening because 0.8 is, decently close to 1.